4.7 vapor and humidity. Evaporation. Evaporation is the transition from the liquid phase to the gas phase that takes place below the boiling temperature. Some of the liquid molecules of the surface of the liquid gain kinetic energy from adjacent molecules and leave the liquid as gas molecules. By doing so, kinetic energy of the surrounding liquid molecules reduces and they cools down. No external heat source is required for evaporation, vaporization or boiling. Vaporization is the transitional phase of an element as it changes from a liquid phase into gas phase at a temperature greater than or equal to the boiling point. In order for the boiling to take place, continuous heat supply from an external source is necessary. Vapor pressure. Partial pressure exerted by the vapor of a liquid is termed as the vapor pressure. Saturated vapor. When a confined space contains as much vapor as possible in that space, then the vapor in that space is called saturated vapor. Usually, a saturated vapor is in contact with its own liquid surface. However, limiting condition is possible with no liquid in contact. That is when the moisture content in the space is marginally sufficient to saturate the space. The amount of vapor pressure for saturation of a given confined space increases with the temperature. Saturated vapor pressure. Saturated vapor pressure is defined as the pressure exerted by a vapor which is in thermodynamic equilibrium with its condensed phases, that is liquid phase or solid phase, at a given temperature in a closed system. The saturated vapor pressure is an indication of a liquid's evaporation rate. Since the amount of saturation vapor increases with the temperature, saturated vapor pressure also increases with temperature. Variation of vapor pressure with temperature. Variation of vapor pressure with temperature can be graphically represented as follows. As shown in the figure, saturated vapor pressure rapidly increases with the temperature, and at a particular temperature, that is where the space exceeds its dew point temperature, then the space becomes unsaturated, and unsaturated vapor pressure is increased proportionally to the temperature, as in the case of a perfect gas. Variation of vapor pressure with volume. Variation of vapor pressure with volume can be graphically represented as follows. As shown in the figure, as we increase the volume, initially the saturated vapor pressure will remain constant until all the liquid phase molecules are vaporized. After that, as we increase the volume, the space becomes unsaturated and vapor pressure drops rapidly. Dew point. The dew point is the temperature to which air must be cooled to become saturated with water vapor. When cooled further, the airborne water vapor will condense to form liquid water, which is called dew. When air cools to its dew point through contact with the surface that is colder than the air, water will condense on the surface. Absolute humidity. Absolute humidity is the mass of water vapor, that is the mass of moisture in unit volume of air. SI units of absolute humidity is kilograms per cubic meter, and its dimensions will be ml-3. Relative humidity. Relative humidity is the ratio of the current absolute humidity to the highest possible absolute humidity under the current air temperature of the space. So that definition of relative humidity can be written as an equation form as follows. Here we can see the absolute humidity is the amount of water vapor available, and we know that vapor pressure is directly proportional to the amount of vapor available. Therefore, instead of current absolute humidity, we can write current vapor pressure. On the other hand, the highest possible absolute humidity is the absolute humidity at saturation. Therefore, highest possible vapor pressure is the vapor pressure at saturation. Therefore, we can rewrite this expression for relative humidity as follows. Relative humidity is vapor pressure of water at room temperature divided by saturated vapor pressure of water at room temperature, which in turn equals to saturated vapor pressure of water at dew point divided by saturated vapor pressure of water at room temperature. Usually, relative humidity is expressed as a percentage. Here comes the experiment determination of relative humidity using polished calorimeter.